Hi everyone, welcome back to Code Eater. In today's video, we are going to see how we can create our own decentralized application from scratch. So in this video, you are going to learn the step-by-step process of creating your own decentralized application. And not only that, I will be also providing you with a template that you can copy paste and create your own decentralized application. So this video will be a different kind of a video because this video is not about React.js or CSS, because I have seen so many YouTube tutorials which are only talking about CSS and the React.js part. But in this video, we will be seeing the actual fundamental basis of decentralized application. So let's start. Now let us look the website, the decentralized application that we are going to create in this tutorial. So this will be a very simple decentralized application, but in this decentralized application, we are going to understand each and every important concept which is required in order to create your own decentralized application. And the best part of this decentralized application is that it is deployed on netlify.app so that you can also copy this particular URL, and I will provide the link of this URL in the description, and you can go to this particular URL and access my decentralized application. And we are also going to see that in this particular tutorial. Okay, now in order to access this buy chai decentralized application, first of all, the user need this MetaMask wallet. Once he will enter his or her MetaMask wallet, you will see a list of all the transactions that are done previously will be shown here. Okay, so you can see that all these transactions that are done. Okay, and we see the connected account. So the connected account means the account that is connected, this account 0487, this account is connected to our decentralized application. And these are all the transactions that had actually happened in the past. So we have the time. This transaction was done by the name of Chidij, and my name is Chidij. This is the date at which this particular transaction actually occurred. This is the the message the user want to send, and then we have the wallet address of the user. And in the same way, let's say I want to do another kind of transaction. I will simply go, let's say Kiara, okay, and then I will just write message as a good job or something like that, okay, and I will pay to the owner. So once I will pay to the owner, I have to again access my MetaMask wallet and I have to confirm for this transaction. Now I need to wait because this transaction is done on Gorilla test network and it will take some time to get confirmed. And here our transaction is successful. Okay, so the transaction is successful. We will click on OK and our page got reloaded. And now we have the new transaction by the name of Kiara, and it was done at 2:57 PM, means according to Indian Standard Time. And this is good job. And this is the address that I have. Okay. So this is the cool decentralized application that we are going to create. And just one thing, in the upcoming tutorial part, you might see a different layout of the website, which will be in yellow color or something like that. Just don't worry, because I have changed the CSS part a little bit, and I will be providing the CSS part and everything in the description of this video. So you will be having the GitHub link so that you can directly access the CSS part. So the website UI might be look different, but the concept will never be changed. So just keep on watching it, and at the end I will be sharing the CSS and everything for this website. Now before starting with our decentralized application code, it is very important to understand how our decentralized application work, or what is a decentralized application if you do not know about it. So our decentralized application consists of two parts. First one is frontend and another part is our smart contract. For our decentralized application project, I'm going to use React.js to code this particular frontend and Solidity to create this particular smart contract. Now, one important point to notice here is that this frontend actually belongs to a real world part, right? And this smart contract belongs to a blockchain world part. So these are two different worlds, right? These are two different worlds. How they are going to communicate with each other? Because this is something belonging to a real world, this is something belonging to a blockchain world. So we need a medium, right? We need a bridge so that these two different technologies can communicate with each other. And for that, what we are going to use is we are going to use Ether.js library. So this Ether.js library will actually help these two different worlds in order to connect with each other. And this way, we are going to create our decentralized application. You can clearly see it is a very simple process, right? First of all, we are going to create our smart contract, then we are going to create our front-end code, and then we are going to use our Ether.js code in order to communicate these two different worlds. So let us understand how we are going to create our smart contract, what algorithm that we are going to use in our smart contract. And it will be a very simple, straightforward algorithm where a user will visit our website, and let's say he wants to buy some coffee or chai. He will provide me, he will send some money to this particular website, and after the transaction is successful, then some person from this particular company will provide the chai or coffee to this particular customer. And not only will this person will not only be sending some money or cryptocurrency, actually he will be also sending some messages, and this message can be anything. Let's say just have a you have a nice day, or please it can be anything, right? It can be a feedback or it can be a message, whatever this person actually wants. So this is a very simple smart contract, if you will see. And the reason for taking this simple smart contract is that I want to demonstrate you how actually a decentralized application works. Okay, in our upcoming projects in future, definitely I will be creating more complicated projects, right? But for now, as a beginner, I think this project will be more than sufficient in order to understand the functionality of a decentralized application. Now, before we start creating the smart contract part, let me show you some data types that we are going to create for our smart contract. I want to just I want to illustrate you all those data types so that you can easily grasp the smart contract. So the first data type that we are going to create is of struct type, and this struct is a memo. Means in this memo struct, we are going to have the name of this memo, the message that you want to send, at which particular time this memo has been created, and from which address this memo has been generated. So this memo, as you can clearly see, will have all the messages: name, message, timestamp, and from, which will look something like this in our uh, in the memory of our smart contract. Okay, so we will have the name, we will have the message, timestamp, and from. Then the another data type that we are going to create will be an dynamic array. Okay, it will be a dynamic array. And we have talked about all these things, right, in detail in the Solidity tutorial. So if you haven't watched that tutorial, please watch that tutorial. It is available on YouTube. Okay. So this memos variable will actually help us in accessing the different memo that are present inside this dynamic, right, in this dynamic array. And this dynamic array will be actually pointing to these different structures. So at, let's say, at memo 0 we have this particular structure, at memos 4 we have this particular structure. Definitely all these will be filled, but as you can clearly see that I do not have space here to illustrate that, but you can clearly see, right, that this memo array will consist of all these different structures, so that we have the information regarding all the memos that we are receiving. So if someone is doing some transaction, we are actually storing that transaction inside this memos array. Okay, so now it's time to go to our remix id and let us code this particular smart contract. So at first we will create our smart contract in our remix id so that we can check and everything, and then we will paste this smart contract to our decentralized application, and I will tell you the whole process, so just don't worry about it. So first of all, I am on my remix id, and then I will create one file by the name of, let's say, chai.sol. Okay, and inside this I will simply copy paste these two lines and simply paste it here. Now we'll just zoom in a little bit. I will write my contract. The contract name is chai. Okay, now inside this, as we have seen, we will create our struct memo, and this will be having the name, having messages actually, or message actually, right? Message, then the timestamp, and then the address from. Okay, and then what we will have is we'll have the memo array, and we have seen this as well, right? For now, what I can do is, for now, let me make this public so that I can show you how this is working. Instead of that, let me make this like this one. You will understand why. Then we will create one constructor, and inside this constructor, what we will do is we will set the owner of our smart contract. So let me create one owner, and this owner will be payable in nature. The reason is very simple, because this owner is going to receive funds, right? So if we want to make some address to receive fund, we need to make that address payable. So if you want to, if you have an address and you want to transfer or receive some ether, in that case, you need to make that particular variable, address variable, a payable address variable. So we will set the variable, and we will do message.sender. As we will do message.sender, you will see an error, right? And the error is that you cannot directly basically assign a normal address to this payable address, because this owner is a payable address, right? So what I will do is I will simply typecast it to a payable address. Okay. And then I will create a function in order to buy the chai, right? So we have seen that a customer will come. Okay, it should not be fine, right? It should be, my mind is somewhere else. So yeah, so what I'm trying to say here is that if a customer is coming to your website, you want to give this functionality that they can buy chai from you, right? And not only they can buy chai from you, but they can also send some messages to you. Let's say string name, so this will be the person name, and instead of memory, let's have call data, right? Because we are not going to change anything inside the name. So, and then we will have the message, and then we will make this function a public function, and let me make this payable. Or instead of it public, we can have external, right? We are not going to call this function within the contract, so it will be fine if it's external as. And this will be a payable function because this function will be helping us in order to receive ether, right, from this. Let me have one require statement dot value should be greater than 0. So if someone is sending some ether to us, we will make sure that they are sending some amount of money to us, right? And definitely it's totally up to you. If you think, okay, I want this particular amount of money, then you can have a functionality like msd dot value should be equal to, you know, 0.1 ether or 0.01 ether. It's totally up to you. I'm just having message dot value greater than 0, so that anyone who wants to buy some chai, I'm going to provide him this. It should be, the money should be greater than 0, right? It's totally up to you. Otherwise he will throw an error that please pay at least more than, or we can have please pay more than 0 ether, right? Okay. And then if this will work out, if the message dot value is greater than 0, in that case we will simply transfer the money to the owner, right? Owner of this contract will have the message dot. That's nice. And then we can push this particular information, this particular data, right, to the array, right, to this memos array, which will actually consist of this memo type data. So what I will do is I will simply do push, and then I will have my memo, this structure, right? And then inside this we will have the name, message, and timestamp, log.timestamp, actually log.timestamp, and we will have the message dot sender, right? So this name will be the person, whatever this person will pass to this particular function. The message will be passed by the person. The block.timestamp will be the current block time, right? And we have talked about all these things, guys. If you haven't seen my Solidity tutorial, please do watch it. Okay, I've talked about all these basic things in great detail there. So block.timestamp is simply the current block time, right? This is the current block time at which this particular function will be the part of a block. And then we have this message.sender, means the person who is actually calling this person, right? So I will show you that as well. So that address will be inside this message.sender, and that will be fed to this from address. Okay. And this way we have completed our buy chai function. And in order to fetch the transaction, I can have this get memos function. Okay, view returns and memo. So it will return the array, right? The array that we have pushed the information, and it will simply return that. Now let us check this. Okay, and that's why I have created this smart contract inside this remix ID. You can easily check this out. We can do is simply deploy this. We have this chai instance. So now we have these two functions, and this person will be the owner of our smart contract. Okay, let us do that. Let's have this particular address. Let's say this particular address is sending, let's say, some 1 ether. Okay, in order to buy chai, it's a costly chai, I must say. And let's say the person name is, for example, Arjun, and the message is, you are a good shopkeeper, something like that. And we will do this transaction, and this transaction, as you can clearly see, it is successful. We will simply get memos, and we have all the information fed by Arjun. So if this, so we have Arjun, the name of the person, because we have fetch, have input the name, right? And the message, you are a good shopkeeper, and the current block timestamp, which is actually in Unix timestamp, which we will convert into a human based timestamp, right? And then we will have this message.sender, the person who has actually called this buy chai function. And as you can see, this is the person who has called this buy chai function, right? This buy chai function. And then if you will see, have all the information, do not have anything else. And in this way, we have completed our smart. Let me show you one more thing, one more example. Let's say some person is sending some 500 way, is calling this buy chai by the name of, let's say, Karan. You are like, you are good, something like that. Transact, get memos, and we have all the information relating to this particular transaction as well. So current, you are good, and all the information is given inside this memos array. So the first part of our decentralized application is complete, right? So we have this whole smart contract. We have to simply copy and paste this to our Visual Studio Code. Okay, so I am in my Visual Studio Code, and it's a very simple installation process. If you want to install Visual Studio Code, just simply go to Visual Studio Code and you can simply install it. It's a very simple process. And then simply I will create one folder here. I will go on open folder. I have my child app. I have created this child app and I will select folder. Yes, I trust the author. So now I have my child app. Now I will open my terminal by either going to doing control plus backticks. It will open my terminal, or you can also go for this terminal option given in the Visual Code. Now inside this, I will simply first of all install Hardhat. Install Hardhat. Okay, and now since my installation is done, I will do npx hardhat. Okay, once I will do that, you see a lot of options. Just click on this first option only, just press enter on it, create a JavaScript project, then enter, and okay, wonderful. So now you have your Hardhat, okay, project inside this, means Hardhat tool inside it actually, and then install these extra dependencies that are provided here. Just copy this down. Okay, and in future the installation means you might see a different version, so either go for that version, don't get confused, or you can directly install this version that I am using. It's totally up to you. If you have some error, then definitely I will suggest you to install these particular version only, and then I will install these dependencies. Okay, so this is done. If you are seeing some error, then I will suggest you to just go to your system administrator path. Okay, just right click your command prompt with system administration, and then you can directly go run as system administrator so that you can install these dependencies if you are seeing any error. Okay, otherwise it's totally good. So now inside this, we have this contract, but we do not require this. We have already created our own smart contract. This one, right? Paste this contract. Let me change it to try.sol. And in the scripts folder, we have this deploy.js. Need to make some changes to it as well. Need to, first of all this, remove all these things. Okay, this part. And then we remove this filler part as well. Okay. Yes, so we will have like this, and instead of log, definitely we are actually because we are not having a log, we will have a chai variable, and definitely it's these are just variables. Okay, so you can have log as well, that's totally up to you. And instead of log, we will have the chai, okay, contract, this actually this part chai, and in like this we will move all this because we are not passing anything to the constructor, right? We have a constructor, but we are not passing anything to this. Okay, so not have anything here, and instead of this, right, I'm telling you what we are trying to do here is, and we will simply, okay, so the first line is actually fetching the artifacts from your smart contract. So once you compile your smart contract, you have this ABI and bytecode, right? So you are fetching those information, and then from that you are creating the instance of your smart contract, and then you are deploying your smart. And I have explained again all these things in my Hardhat tutorial. If you haven't watched that, please do watch. Okay, so let me explain here as well. Fetching artifacts, fetching, or I will say fetching bytecode and ABI. Okay, and then we are actually creating an instance. Okay, creating an instance of our smart contract. Now instance is something, or you can say an object of your smart contract, so that you can talk to your smart. Okay, you do not need to go in depth of these. Okay, these are just configuration files. I'm just explaining you if you want to learn more about it, but if you want to learn more about it, you can go to the hard hat documentation as well. But these are the things you just need to know this much only, okay, for now. And from this line you are actually deploying smart contract, okay. And in this line we are simply fetching, means once we will deploy our smart contract, we are actually fetching the smart contract address, okay. And you will see this in action as well, so don't worry about it for now, right? Don't worry. Now what we will do is we will delete this folder. We do not require this, okay. Let us quickly deploy this smart contract on the Hardhat local node, okay, so that we can check whether it is working fine or not. I will show you some parts of this. Npx hardhat compile. First of all, let me show you how this works. So it is downloading the compiler, okay. So compilation is successful, and you will see that as soon as compilation is successful, right, we have the artifacts, and we are actually fetching these artifacts here, okay, so that we can deploy the smart contract. You will go to the contracts part. So we have the artifacts folder, then we in the contracts folder we have this chai.sol, and inside this you have this chai.json, and this is actually consisting of your bytecode and your and your ABI. So this is your bytecode, which is going to get deployed on the on the blockchain actually, and this is your ABI, right? This one, ABI. Okay. Now let us deploy this. Okay. Let us deploy this. Now let us write npx hardhat run scripts. Okay. So inside the scripts folder, I am going to deploy .j. Let's check, and you can clearly see, and it is actually getting deployed on the local blockchain of this Hardhat only, okay. So you will not be seeing any blockchain, but it is actually running, okay, behind the back, or I will say at the back, something like that. Okay, so we have this smart contract address, and our deployment script is working perfectly fine. Let me clear this for now, and now what I will do is I will do npm create yt white at latest, okay. So this will actually help us in installation of our React.js, because earlier we were using create React app, right? But if you will go to the React.js documentation, they have removed it from there. So this is something new. Like you can use white also in order to install your React. Nothing will be changed. If you know React.js, everything will work like that only. So do not get confused. Okay, I do only know React and you are using some white. No, I'm not using some white. White will actually help us in using React.js. Okay. So you have so many options, and I'm going to select React from. I will just press enter and the JavaScript only, and you will see that you have your React folder. So this is our white project, right? White project, and I want to change the name client for now. Okay, then we will simply do cd client, yes, and then we will simply follow the step npm install and then npm run the install. So it will install all the packages available in the package.json, and this is the procedure that you have to follow every time you are creating your decentralized application. So in the first part, you need to install either Truffle or Hardhat. In our case, we have installed Hardhat. We have created some everything for our smart contract. And in the next part, you need to install your front-end code, like front-end technology. Since I'm using React.js, I have my React code inside my client folder, right? So inside my client folder, I have my React code, and above and below, you can see the smart contract code, or I will say the Hardhat code. Okay, you have to follow this procedure each and every time you want to create your decentralized application. Just clear this all for now. Now let us check this whether it is running or not. So I will do npm run dev. Okay, so now it has started on this particular localhost, and at this particular port I will simply follow link. So here you can see that my localhost at localhost 5173, I have my React.js code running. Okay, now it's time to create the code for our React application. We will go to the client folder, and inside our client folder we will go to the source folder, and inside this we will go to app.jsx, and in this we will remove each and everything that is given here, because we are going to do everything from scratch. So yes, we do not need to have all these this as well, and I think this is good. Now as a first step, we will create the template of our decentralized application. As I said, right, we will be creating a template so that we can, you can use that template each and every time we are creating our decentralized application. So in the first step, we will be doing that. Okay, and for that, what we will do is we will have use effect. Okay, and I hope you know a little bit of React.js because we are going to use that. And then what we are going to do is, first of all, we will create one use state. In this, we will have the state set state, and then we will use the use state, and inside this use state we are going to initialize this state variable. Okay, we are going to initialize this with an object, and this object will consist of three things. First of all, it will consist of the provider. Okay, that will be null initially. Then we will have the signer. This will be also null initially. And then we will have the contract instance that we will be creating. Okay. And that will be also null initially. Okay. Then what we will have is, okay, what we will have is, we will have a user. Okay. So we will have our use effect. I'm using this use effect because I want that whenever my React application is running, okay, whenever my decentralized application is actually running, I want that it automatically fetch my contract instance. I do not have to click any button in order to create an instance. Okay, and for that I'm using use effect here, and inside this use effect I will create one function by the name of, let's say, template. Okay, because we are actually creating a template, right, which we are going to use each and every time, right, again and again, whenever we have to create our decentralized. So this will be our template, and inside this template we will have certain information. And for that, let me make this async because it will have a lot of promises, will have a lot of await. And inside this, now we will have certain things. First of all, we will have the contract address, which we will paste it afterwards, but for now let me have it empty only. Okay, or I can do something like this for now. So the first part of our template will be the contract address. The second part will be the ABI. Okay, so the contract ABI. Okay, and we'll have it afterwards. Now inside this, what we will do is we will write the code in order to connect to our MetaMask wallet. What we will do is we will deploy this smart contract. Okay, we will deploy this smart contract on the GoRally test network. Okay, on the, or I will say on the fake blockchain, right? Ethereum, because testnet, it is a test net. We are going to use fake ethers, right? So we will deploy this smart contract on a GoRally blockchain or GoRally testnet. Okay, and since we are going to deploy this smart contract on a GoRally blockchain, we need to communicate to this smart contract, right, which is deployed on the GoRally blockchain. And for that, we are going to use MetaMask so that we can create our transactions, right, with the help of MetaMask. Because whenever we are going to do anything that is going to change the state of our blockchain, we need to pay some amount of money, right? And we have discussed this, like I have discussed it in the Solidity tutorial as well. And not only that, our MetaMask will also provide us the functionality to connect to the GoRally test network, because our MetaMask at the end of the day consists of this Infura API, which actually help us in connecting to the blockchain. Because our computer, for now, this computer that I'm using, it is not capable enough to talk to the blockchain, right? Because this is not connected to the blockchain. So MetaMask will help us in these two different ways. Okay, so here we will have the MetaMask part, MetaMask part. Okay, and why we are using MetaMask, let me write that down as well for you. We are using MetaMask in order to do transactions on GoRally testnet. Okay, and second thing is MetaMask consists of Infura API, and I will show you that as well when we will deploy our smart contract, which actually help us in connecting to the blockchain, you could say. Okay, so we will be able to connect to the blockchain, which is actually the different world. Now, in order to fetch this MetaMask wallet, okay, I will do const Ethereum. Okay, so this MetaMask wallet actually inject this Ethereum object inside our window. So what we will do is we will fetch it from the window. Okay, so we have this particular account, right? So this account will be inside our account variable that we have. And let me show you the Infura part as well. We will go to settings, we will network, GoRally test network. So in this you will see we have this RPC URL, and this RPC URL consists of this Infura, right? And that's what I said, that this will be actually helping us in talking to the blockchain. So it is like we are connected to the blockchain, which is on a different network. Okay, now in this account we will have this Ethereum. So this is something related to your MetaMask request, and with the help of this will method, you will see what it will show you that. request account. So this will actually automatically open your MetaMask wallet whenever a user will visit your website. So let me save this, okay, and I will show you this. I have a dependency list for now. Let me call this template function, right? Call this. Let me see. It will look like this. Save this. Let me go back. So we need to log out from our MetaMask wallet so that we can check the function. Okay. So now let me refresh the browser. So as soon as I will refresh my browser, you can see that my MetaMask account gets open, and this is because of this Ethereum.request method. Okay, this Ethereum request account methods that is actually provided by MetaMask wallet. Okay, close this for now. Now what I will do is I will have my provider. So this was your first step. So this was actually your first step, right? We can write it as first step, fetching the address and the ABI. In the second step, something for the MetaMask, and definitely not only MetaMask. Let's say if you want to connect to Ganache or let's say anything else, you can have that functionality here. Okay, so that's thing. And now we will have the provider. Now this provider is something which will actually help us in connecting with the blockchain. And for that, we are going to use the Ethers library. It's actually provided by the Hardhat only providers. Okay, and in this web3 provider, and in this we will have the Ethereum, okay, this object. Now the second step, we will have the signer. And why do we have a signer? I told you this in the Ether.js tutorial. Hope you have watched that. If you have not, let me tell you in brief that signer is something which will actually help us in doing transactions that are going to change the state of the blockchain. This provider is something which is actually helpful in reading the blockchain. Okay, so this will be used when you want to just read the blockchain. And if let's say I want to write on the blockchain, right, or there will be certain times where I want to do something which is going to change the state of the blockchain, and for that I need provider. I will get the provider, sorry, not provider, actually signer, and this will actually help us in writing blockchain. And once you have this signer and this provider, now we have everything ready, right? So what we will do is we will create the instance. So an important point to note here is that when you have to create your instance, you require three things. So new ethers dot contract. So this is a syntax with the help of which you can create your instance. And inside this instance, you pass three things. First one is the contract address, which we will pass, means I have already created. We need to just have the address. And another thing that you will require is the contract ABI, okay? And then we will have the signer, okay? Now, let us understand this. Why do we need to have a contract address in order to create your instance? See, whenever you are going to talk to your smart contract, right, which is deployed on the blockchain, so you need to tell, okay, this is the place where my smart contract is deployed, so I want to go to that place. Okay, so now you have reached to that place. Now, once you have reached to that place, to that contract address, you need this contract ABI. Why do you need this contract ABI? You are going to need this contract ABI because once you have reached this place, you want to talk to your smart contract. And as we have discussed in the Solidity tutorial, that in order to talk to your smart contract, you need this ABI so that ABI can help you in talking to your smart contract. And that's why we need this contract ABI. So if any third party application wants to talk to your smart contract, you need that particular person or that particular party will require the contract ABI. And that's why we have this contract ABI. And then we have the signer so that we can do all sort of transaction on this contract. So these are the three mandatory things that you require whenever you are creating an instance of your smart contract. And this instance as a whole will actually help you in talking to the blockchain. Okay, so that's the thing. And let's create one more basically use state, and that will be account one. Set account use state, and initially we can have not connected, something like that. And once our account is connected, we can set the account here, right? So once we have our MetaMask account, have that particular account set here. And then once we have the instance of our smart contract, we can set the state. And inside this state, we will have the provider, we'll have the signer, and then we will have the contract. This is what we have created, right? Above. So we have created this, right? Okay. So this is done. What we can do is one more thing is that we can have a try and catch block, because sometimes there will be times when a person will not have a MetaMask wallet, right? So in situation like these, what you can do is you can create a try and catch so that you can catch that particular error. I can have a try block. I can put this part only because we will have error in this part most of the time. Or let's have all these things now. Okay, and we will have a catch so that we can catch the whatever error we have. We can catch with dot log, or what we can do of console.log, we can have an alert message. Okay, so this is your template, right guys? But definitely it is not totally complete because we do require the contract address and we do require the contract ABI so that we can complete the functionality of this particular template. For now it is an incomplete thing. Okay, definitely, but I have mentioned all the important steps that you need to create your template. First your contract address, then ABI, then your MetaMask or any other blockchain that you want to talk to, and then simply set your provider, signer, and all those. This is the basic functionality that you have to follow whenever you are creating your application. Now it's time to deploy our smart contract. And in order to deploy our smart contract, we will again go back to the Hardhat folder. So we can close it for now. Okay. So this is our smart contract and we want to deploy it on GoRally test network. So in order to deploy it on GoRally test network, I will paste the following script and you can copy this script. I will provide the link in the description, GitHub link in the description, and you can copy this particular script. Now, once you will do that, you will see that here we have two different fields. First one is GoRally URL, okay, and the another one is this private key, okay. So this GoRally URL, you are going to fetch it from Infura or from Alchemy. So you can go for either Infura or you can go for either Alchemy, and I will show you, don't worry about it. And this private key, you will get this private key from your MetaMask account. So I am on Alchemy. I'm going to use Alchemy. You can also choose Infura, okay. And for what I will do here is I will just copy this down, not actually copy this down. Okay, so I am on Alchemy, and in order to access Alchemy, in order to use Alchemy, just type Alchemy in your Google and just sign up to Alchemy. You will have this kind of dashboard, and just create on this create app option. Okay, and then write the name. Let's say this is my coffee Dapp, for example. This is my coffee Dapp, and in the description, running website. Okay, and then instead of mainnet, I will choose GoRally test network, and then I will create my app. So once I will do that, I will have my key here. Okay, so you can see that I have this API key, this link, and this link. So I will copy this API key, and yes, to keep this API key safe. Okay, because if you will, by chance, if you will reveal this API key to anyone, then and you if you are having some amount of money, connected to your Alchemy, then your money will be detected. So keep this URL private, API key private. I'm accessing it in front of you because this is just a demonstration tutorial. I will delete it afterwards. So do not reveal this API key. Okay, and then we will go back. And now what I will do is I will install one more thing by the name of .env. And once it will be installed, what I will do is I will create one more file by the name of .env. Okay, and we are doing this so that we can keep our private key and the URL safe. Okay, so first of all, I have this GoRally URL, right? So I will just paste my API key. First of all, take my GoRally URL variable. Okay, just take this one and paste it here and equal. In the same way, now we require our private key, and we will get our private key from MetaMask. So I will go to MetaMask and I will open it, and I will simply copy this, not actually copy this, I will just go to account details and I will export my private key, and I will type my password so that I can have my private key. I will confirm it. So now this is my private key. Again, this is something which you have to keep private. You do not need to share this because this is something very important. So again, I will paste my private key here. I will go back to the configuration. I will copy this variable, paste this here. Okay. So I'm simply accessing these two variables, right, inside my Hardhat configuration. Okay, from this .env. So I'm accessing both of these two variables. Save it. Okay, so now we are ready to deploy our smart contract on GoRally test network. So this will actually help us in accessing the GoRally test network, and this will actually help us in accessing my MetaMask account in my case, right? So I will simply now deploy this smart contract. So let me clear this and write npx hardhat run dash dash network, then go really. Okay, I'm accessing this particular thing, and then simply scripts slash deploy.js. I'm actually deploying my smart contract on the Gorilla, not Gorilla, yeah, on the Gorilla test network. So I will just press enter. If everything will be correct, it will get deployed. Okay, so there is some issue. Check. Okay, I made one mistake here, I think. Okay, instead of URL, I have provided this API key. That was my mistake. Let me go back and let me have my HTTPS, this URL. Okay, so let me paste this here now. Now it is good. Now let me try once more and let's run this. So it will take some time because it is getting deployed on blockchain, right? On a Gorilla test network. So it will take some time. And once it will deployed, we will have the contract address, and we will get this contract address because of the deployment script that we have written. This deployed contract address. Let's see. Okay, good. So this is our smart contract address. Let me copy this down and let me paste the address here so that we can check it, search for it. And this is our transaction. So this is done 34 seconds ago. So we have successfully deployed the smart contract on the Gorilla test network. So we will be requiring this smart contract address again and again. So what I will do is I will paste it here. You can also paste it so that you do not forget it, and just copy this down. Just go back to your client, then go to the source, then go to the app.jsx, and then simply paste the address here. So now we have the contract address. And one more thing that we will require is this ABI, right? So what we will do is, let me create one more folder here by the name of contract. Okay, or we can also name it as contract JSON. Okay, let me write it as contract JSON. And what I will do is I will simply go to the artifacts and I will simply copy this file from here to this contract.json. Okay, so what I will do now, I will simply import this file inside my app.js by import ABI from current directory, and the directory name is contract JSON or JSON, and then chai.json. So I'm simply fetching the chai.json that I have created inside this contract JSON. Okay, and you will have this artifacts whenever you are going to compile your smart contract or whenever you are going to migrate your smart contract. In all the cases, you will have this artifacts. So just copy this chai.json and just paste it here. Or there is one more method I will show you. Okay, and if I do not forget, just you have to remind me. But how you're gonna remind me, right? So what you can do else is, or let it be for now. Okay, let it be for now. Just copy paste it for now so that we can do this. And I will tell you that method. Okay, in that method, what you can do is you can have a script inside your Hardhat configuration, which will actually tell where your chai.json will be formed. But we can do that in this manner also. So let's do it for now in this way. And what we will do is, in this ABI part, we will simply have the ABI.ABI. So we are simply fetching the chai.json ABI from this particular chai.json. And now we will simply save this. So now we have everything ready, right? In order to create the instance of our smart contract. Let's see this as well. Pull this up. Let me clear this. Let me run this once. Let me again run this. Yum run dev. Okay, there is some issue. Okay, I think I'm in not my client folder. Let me go to my client folder and then let me run this npm run dev. So let me open this. Okay, we have some issue here. Let me check what is the issue. It is saying that reference error ethers is not defined. So just import. Actually, I haven't imported ethers. So let me import it. Ethers from ethers. Okay, now this is good. Go back and check it. So now you will see that we do not have any error, right? So our MetaMask is already open. Okay, I think it's not open. Let me type my password here. Let me refresh. Okay, now this is so now we have our decentralized application template is ready. So we can check this template by going to console.log contract. Okay, let's see whether our instance is ready or not. So again, go back, and this is our instance. You can clearly see. So this instance is having our contract address. This is having our function. This is having our another function. I think these both of these are the same functions. Means the thing is that we have everything that we require in order to interact with this instance of our smart contract. Okay, so this is good. This is good. So remember this thing. Okay, remember this template. And do not get confused. Like in the second part, I told you, right, that we can use MetaMask in order to connect to the blockchain. We can do that. There is no issue in that. When if we had deployed our smart contract using Remix ID, in that case we would be using MetaMask, okay, because we will connect our Remix ID to MetaMask, and then MetaMask will actually help us in deploying to the blockchain. In this case, we have used Hardhat in order to deploy our smart contract on the Gorilla test network, and now we have the address, so we are just using that particular address. You can also go to your Remix ID. You can use MetaMask in order to deploy your smart, actually not, MetaMask is not actually deploying your smart contract. Remix ID is actually deploying your smart contract, but MetaMask will actually provide you with that Infura key. But in our case, since we have used Hardhat, that's why I have provided the API key, in this Hardhat configuration part. Okay, so that's why. Okay, so now our first step is ready. Now it's time to create some components so that we can do all of our work that we require in our decentralized application. So now it's time to create our component. And in order to create components, we will go to our client folder, to our source folder, and in this we will create one folder by the name of components. And inside this, we will create two files, one by the name of buy.jsx and another by the name of memos.jsx. Now inside buy.jsx, we will have buy, okay, buy, and inside this return nothing, and then we will simply export default. Now we will do the same with the memos.jsx, and in this we will have memos, and here we will have memos. Okay, so this is done. Let us check whether it is working or not by importing these two components in the app.jsx. So we will do import, and inside this we will have memos from memos.jsx, and then import buy from buy.jsx. Right now what we will do is we will simply use those components here by having buy and then by having the memos. Okay, so let's do one thing. Let's write something hi buy, and in the same way hi memos. Let me save this, let me run this. Okay, I have to cd client and then run this. So if you will see in your screen that we have this hi buys and hi memos, so all our components are working. Now, in order to use these components, what I need to do is I need to pass this state that we have set once we have the provider, the signer, and contract. And you will understand why we have done this, why we have set all these things in an object. We will simply do state. So we will pass this as a prop state. Okay. And in the same way, we are going to pass this state in this way. Okay. And for now, let me comment this out, because currently we are going to work on this buy component, and I do not want that this component interferes in that. So that's why I have commented this out. But once we will complete this buy component, then we will work on the memo.jsx component. Okay. And one thing what we can do more is, since in the decentralized application that I have shown you, right, we have this connected account functionality. So let us have that particular functionality in this. How we can have that? We have to simply write here. I will improve the CSS. Let me first of all write it down, connected account. And inside this, we will simply have this account. Okay. The account that we have set here. Okay. This MetaMask account. So we will have this account. Okay. Let me do this. Let me check this. Okay. So it is saying not connected, and we will improve the CSS part. Don't worry about it. For now, I'm just working on the logical part. So let me go to MetaMask and let me now refresh it. So now you can clearly see that we have this connected account, and the connected account is the MetaMask account that we have here, right? If I will change this account, so let's say if I will go to some different account, let's say to this account. So not this, we are already on this. So I am on different account, right? So I will refresh it. So you can see that we are on different account. Now, one problematic thing that I'm finding here is that whenever I'm changing the MetaMask account, right, the screen is not getting reload, right? We need to reload this button again and again, and I don't think so it's a very good type of functionality. So what I will do is I will simply have one more method, okay, So this method name is window.ethereum.on, and it is for accounts changed. Okay, so accounts changed, and it will actually call a anonymous function. And in this we will have window.location.reload. Okay, and save this. Let me go back. Now let me try to change the account. So let's say I am on this account. Okay, let's say on this account. Okay, I think I haven't saved the changes. Okay, no, I think I missed this on thing, right? So now it will work. So let's say I will connect. So you can see that as soon as I will change the account, we will have a different account, means the account that we are actually connected to. So this is something, this will be very useful whenever we are changing our account address. It will actually reflected in our browser as well. And one thing more that I have done is I have imported the CSS file, the change CSS file. So I have some CSS applied in our decentralized application, and you can copy paste this thing, because I'm not going in depth of CSS in this particular project, because this project is all about blockchain, right? So you can simply copy paste the code, okay, this code, and you will have the CSS part. So I haven't changed the logical part anything here. Okay, the logic is still the same. I have only added the CSS part, which you can actually got from my GitHub link, which I will share in the description of this video. You will find this image that is attached to this, to this particular project. You can directly have this from that. Okay, so I have inserted this CSS so that it looks some good. Okay, otherwise it was not looking that much good. And definitely we will work on the CSS part later, in the later part of the video. Okay, so yes, so we have the connected account and we have this hi bye. We can remove this hi bye for now, because now we are going to make changes to our buy.jsx component. And to have the CSS part just like this, just copy the app.css part from this and index.css part from this. Okay, you will have a structure which will look something like this if you are doing with me. Okay, now let us go to our buy.jsx. So first of all, what we will do is we will have this particular prop that is passed by app.jsx, that is the state one. Okay, so we will have the state here. And now this buy.js component is all about buying the chai, right? So I will create one function by the name of buy chai function, and this will be an async function. Okay, so it will be an async function. Now we will write the logical part in this buy chai function, but before that, let me create a simple form here. Okay, so let me create a simple form for you. And why do we need this form? We need this form so that we can have the different inputs from the user, and then we will have those inputs as a as an argument to our buy chai function. You will understand that. And for that, what I will do is I will simply create some input for now. So input like this, and I will just copy paste this for now, and then I will have a button. Okay, so I will have a button, and this button is all about pay. So with the help of this button we will be able to pay, and once this button will be clicked, so this form will be submitted, right? And since this form will be submitted, so what we will do is we will simply have a on submit event, okay, which will make sure that when this particular form is submitted, by clicking on this pay button, we will call this buy chai function. Okay, we will call this buy chai function, and in the input part we will have some ID like name. Okay, so we will have name, we will have an ID of by the name of message. Okay, and then we will have, okay, we do not require this one, right? We have the name and the message, and we can simply call the buy chai function. So let us see how it will look. It does not look good, I know. Don't worry. As I said, we will improve the CSS. I'm not having the CSS part in this particular code because I do not want you to get confused. Okay, that's why I want it to be a simple. Okay, I want it to be as simple as much simple it could be, so that you are not getting confused with a lot of CSS and other React components and all those stuff. I just want to make the logical part clear to you so that you can create your own decentralized application whenever you want. Now in this, what we will do is we will simply fetch these two inputs. Why? So that I can call my, let me go to my chai.sol, and I can call my buy chai function. And in this buy chai function, we require two things, right? We require the name and the message. So we will fetch the name and the message from these two inputs. And how we can do that? We can simply write name, and we will simply use the document object dot query selector. And in this, we will have the name right? So that's why I provided this ID name. So this will consist of the input of the name, okay? And in the same way, we will have another thing, that is the message. Okay, so message document.query selector, and in this we will have the message. Now these two things will actually fetch this two inputs, right? So it will actually fetch the input tag. Let me show you that. Okay, so let me show you that. So what do is name and the message, and let me save this. So let us go back. Let me open my console. Okay, I will change this class to class name. Don't worry about it. For now, let me write something, some random thing. Kshitij and something like this, pay. So, oh, there is some issue here, right? As soon as I have clicked on this pay button, my form got submitted and I do not have anything on my screen or I have anything on my console. So there is some issue, right? Actually, the issue is with this form that we are using with React. So React and form are those things which do not go hand in hand together. So we need to have some, we need to use a kind of a trick so that this type of thing does not happen. What we will do is we will pass event, and in this event, with the help of this event, we will make this page default. So event.prevent default. So this will actually make sure that whenever we are submitting the form, our page does not get reloaded. So let me show you this. So let me refresh this. Let me type some random things, pay. So now you can clearly see that our page does not get reload, but definitely we do have some issue here, right? The issue is that in the first part we have the input name tag, right, which is good, but in this we are seeing null. So we have made some mistake, I think. Okay, I by mistake haven't written this hash part. Okay, now it is good. Let us check now. Pay. So now you can see that we have these input tags, but we do not require these input tags, right? What we require is the method that is inside this input tag. So what we will do is we will simply go and we will write dot value, and in this also we will write dot value so that I can fetch these two different values. So let me write their values pay. So now you can see that I am fetching these two values, right? So now what I will do is I will pass these two values in this bychai function. Now here comes the interesting part. Since I want to call this bychai function, I require one important library. And that library is Ether.js library, because our React.js code is not capable enough to talk to this smart contract code, right? And when I'm saying this smart contract code, I'm not talking about this smart contract, right? Because our smart contract is already deployed on the Gorilla test network. I'm just demonstrating this particular smart contract to show you that. Otherwise, our smart contract is already deployed to the Gorilla test network. If we are going to make any changes to this particular smart contract, it will not be a concern for this particular decentralized application because it is connected to this particular contract which is deployed on this particular address. Okay, so for illustration purpose, I am talking about this functions of this smart contract. So since I want to call this bychai function, right, this bychai function, and in order to do that, I need to talk to this smart contract. And for that, what I need is I need Ether.js library. But before that, in order to talk to the smart contract, I also need the smart contract instance, right? Without that, how I'm able to talk to the smart contract? If I do not know anything about the smart contract, how I'm going to talk to that? So what I will do is I will simply use this state thing, right, that we have passed. So I will have my instance by restructuring the contract thing, okay, the contract instance from the state. So now we have the contract instance with us. And now what I will do is I will have my transaction, okay, and this transaction I will be using await because we are going to make call to the blockchain and that will require some amount of time. So I'm saying that, okay, wait till I have done this transaction. So that's why I wait. So wait for this particular line since this until this line is get completed. I'm going to use my contract instance. Okay. And how I have created this instance? I have created this instance, if you will see, using not web3.js, actually ether.js library, right? So now I will simply use this instance and I will call the bychai function. And inside this bychai function, we require, if you will see, three things. Why three things? First, the name, message, and one more thing, that is the amount, right? That's why we have this message.value. So first of all, I will have the name. Okay, I will have my message. Okay, that's good. And the third thing that I need to pass is the amount. Now, how I'm going to pass this amount? I'm going to pass this amount by by passing actually an object, and that object is value. Like that object will consist of the value that I want to pass. Now, instead of directly passing the object inside this, what I will do is I will create one more field by the name of amount, and I will have an object inside this, and this object will have a key as value. Okay, so the key should be value. The key must be value. And what I will do is inside this, I will have the amount of ether that I want to send. Now, the value that we are going to send to our smart contract will be in way, because we will not be able to send ether value. Okay, if you are thinking that I want to send, let's say 0.001 ether. Okay, let's say you want to send this amount of money or cryptocurrency ether, right? So if you want to send 0.01 ether, in that case you need to convert this 0.01 ether into way. Okay, because our smart contract does not accept cryptocurrency in form of ether. So what we will do is we will simply use the ethers library, ethers utils dot parse ether, which will actually convert our 0.01 ether into a way, actually to a big number object, which will be of form of way. Okay, to this amount, and then we will simply transfer this amount here. Okay, so by this, we will be able to send this 0.01 ether to this particular contract. Or I do not have that amount of money. So let's say I want to send 0.01. And if you are thinking, okay, if I want to send some dynamic value, then what I have to do? Then simply create one more input here and then have an amount value inside this. And you can do that as well. What I mean to say is you can do something like this by simply having a amount field, okay, like this. And you can send the money by using this thing as well, right? So what you need to do is, again, you need to create a variable, or let me just copy paste this. Paste. You should have your amount here, and in this you can have your amount, right? So now you have your amount value, and you can directly use this amount value by converting it to into way, and then you can directly send it here. So it's up to you if you want to do that, but for now I'm going to use this particular static method. Okay, and what we can do is we can also wait for this transaction. So what I will do is I will simply do an await transaction dot wait. So once the transaction will be successful, we can actually print the result that transaction is successful. Okay, so now we have this buy chai component totally ready. Let us check this by going to this back. Okay, I think I have one more field. Let me remove this for now. Okay, so now let me refresh this. Let me, let's say my name is Kshitij and the message that I want to send, very nice, for example, and I will simply click on this pay. Okay, there is some error, right? Ethers error. So just quickly import ethers inside this. Import ethers from ethers. Okay, so now this is done. Refresh. Again, my name is Kshitij. Let's say very nice coffee or chai, whatever you want to call it, and then click on pay. Again, we have an error. Let us see. LU must be a string. Okay, it should be a string, right? We cannot directly have a numerical value here. We need to pass as a string. So this is the ether value, and this string ether value will get converted to way value. Let's go back. A lot of mistakes. Kshitij, again, you guys are awesome. Pay. Okay, I do not have that amount of money, it is saying. Wow, that's so great. Yeah, I actually do not have that amount of money. Let me connect it to this particular account. Let's try now. It's good that you are seeing all the mistakes, right? Okay, let's see that. Yeah, for now you can clearly see that. So I have the sufficient amount of money, that is 0.001 ETH, 0.001 ETH, and I will simply click on confirm. Now let's wait. If the transaction will be successful, we will see a result that transaction is successful in the console, and as well as we will get a notification by MetaMask. And again, this transaction is being done on GoDaddy, so it will take some amount of time. And in this page, you can clearly see in this console, actually, the transaction is successful. And if we will go to MetaMask, we will go to the transaction tab beyond Block Explorer. So this is our contract. Okay, not this one. This is from address, and this is the owner address, right? Let me check. So 0487, and this is the, okay, no, yeah, this is, I think this is the contract address because it is showing us contract symbol. So what actually it means is that this particular address had actually sent some money to this particular address, which is the contract address, and from this contract address this money is actually being sent to this address. Okay, this is the same address, right, which has actually deployed the contract. It's okay, that doesn't matter. So let's go back. So our buy chai function is totally working fine. Let me add some CSS to it so that it looks a little bit good. Okay, so now I have added the CSS as well. Let me go back. Let me check. Okay, so it is looking a little bit good. Don't worry, we will improve it, as I said, as we will progress through the course. And now we have a little bit more good structure, I will say. Now let's go back, and now it's time for the memos.jsx, right? So this is our buy chai smart, not smart contract actually. This is our buy chai component, and which is actually totally ready. So now it's time to work on our memos component, right? So I will go to memos.jsx, and inside this I will remove this definitely. Now I will simply have my state here as well because we need to talk to our contract, right? And inside this, what I'm going to do is I'm going to create one state by the name of state memos. It will be a use state, initially an empty array, and then I will create one use effect. And inside this use effect, and the reason for creating this use effect is because I want that my memos get rendered whenever we have some new memos. Like I want my memos to be rendered on screen as soon as my decentralized application is running. Okay, so that's why I'm having this in use effect. And then what I will do is I will have my memos message function, and it will be an async function. Now since we want to talk to our smart contract, what I will do is I will simply have my contract in my state, means I will simply fetch my contract from my state. And then what I will do is I will simply fetch my memos. And how can I fetch my memos? I can fetch my memos by going to the instance, and then by go to the function of my smart contract by the name of get memos. We have created this function, right? Get memos, and it will return us with an array. So let us see this. Let us see this first of all before setting the state and everything. And inside this we will have my contract. Okay, so let me call this as well. And before calling this, what I will make sure is that we do have the contract instance ready. And when we have the contract instance ready, then only we are going to call this memo message function. Okay, now okay, one more thing. Let me have the use state here as well. State. Okay, now let me move back. Let me refresh it. So now you can see that we have our array, and inside this array we have the first payment that we have done, right, by the name of Kshitij. So this is the from, and this is the message, and this is my name, right? So this is the address from which we have done the this particular transaction. This is the name of the person, and this is my message. And let's try to do this once more. Let me have some random name like let's say Jane, or in this message we can have perfect, and we will simply click on pay. Our MetaMask account is opening. Simply let us confirm. Now let's wait. Once the transaction will get confirmed, we will have more than one array inside this square brackets, right? Let's see that. Okay, so the transaction is successful. Let me refresh this, and we have two arrays. So first array is all about me, Kshitij, and the second array is about Jane, and the message is perfect, and this is the address of Jane, and everything is given here. So this is how we will fetch the memos of our smart contract. But our work is not done. What we will do is we will simply set the memos, okay, by having my set memos. And now it's time to display these memos on our browser, right? And how can I do that? In order to do that, what I will simply do is I will simply use memos.map function, okay. Inside this we will have our memo, and what we will do is, for without the CSS, okay, I'm doing this without the CSS and anything, I will simply have the different fields of my memo. So first of all we will have the memo dot name, right? So we have the name. Let me go to the contract so that we can check. So we have the name, we have the message. So let me copy, paste, and then So this is the message, and then we have the timestamp, I think, right? Timestamp and the from field. So we have the timestamp, and then we have the from field. And yes, we need to do one more thing. We need to have all these things in a div. Okay, this, and we will simply return this. Okay, so let us check this how it is looking for now. Okay, there is some issue. Okay, the error is because of this timestamp part, because this timestamp is actually an object. Okay, it is treating this timestamp a big number object. So let me convert this. Okay, let me convert this to a normal time. Okay, by this particular syntax, new date memo dot timestamp into 1000, and then converting it to a local string. Let me save this. Let me go back. So now you will see that our error is gone. And if you will see this, we have the transactions. Kshitij, you guys are awesome. This is the time. So this is at this point of like at 11:45 p.m. I have done this particular transaction, and this is the address. This is Jane. Perfect. Then the time, and then again we have the address of Jane. Now let us improve the CSS of this. Okay, so now I have copy pasted the CSS. Let me go back. So now it is looking a little bit good, right? From before compared to before. So we have the name, we have the names, we have the time, we have you guys are awesome, we have the address, we have perfect. And by this, we have actually completed our decentralized application. The only thing is to check once more just by typing some name, let's say Rina, and the message, wow, and then let's pay for it. And definitely I will improve the CSS, just don't worry about it. Let's confirm. Let's wait for our transaction to get confirmed. So the transaction is successful. Let me reload this. So now we have the third transaction with the message and everything, right? So I have updated the CSS part of our website. Now it is looking good, right? Earlier it was not looking that good, I know. So I have updated the UI part, and now you can see that, let's say if I want to do any kind of transaction by the name of Kshitij, again, nice, and then pay. So my MetaMask is opened. I will enter my password. Okay, so it is asking for the payment. I will confirm. Let's wait. Let me go to the console to check. Okay, the transaction is successful, and let me refresh this. Okay, so now here you can see that we have another transaction that I have done today at 2:44 p.m. Okay, according to IST, Indian Standard Time. Nice, and this is my address. One thing that we can do is, instead of having the transaction during the buy process, let me go to the buy.jsx. So during this, instead of console.log, we can do an alert, right? That okay, the transaction is successful. And one more thing that we can do is that we can reload here. Okay, so that window, once there is a transaction, window.location, we will reload the page. Let's see how it will work. Let's go back. Let me refresh this. Okay, so let me try once more. Let's say Karan is doing the transaction. Good, and then simply pay. Let me pay this. So if the transaction will be successful, we will be seeing an alert box. Yes, so we have this alert box saying that transaction is successful. Definitely you can have a modal also, but as I said, the focus of this tutorial was not to go into the CSS and React.js part, but only to go to the to understand the fundamentals of decentralized application. I will click on OK. So as soon as I have clicked on OK, you can see that the page got refreshed, and now we have the transaction of Karan, right? The good and the address of Karan. So this is good. Now it's time to deploy our React.js code on Netlify so that anyone can use our decentralized application, right? And how we can do that? We can do that by, first of all, let me close this. Now inside the client server, so not server, actually in the client folder, what I will do is I will run npm run and then build. Okay, just press enter, and this will actually give you a build folder. So inside your client folder, okay, I think in white we have this dist folder, this dist. So we will use this dist folder in order to upload it on Netlify. So now we are on app.netlify.com. So on this only we are going to upload our React.js code. And for that we will go to add new site button. Okay, and just it is a very simple sign up process. Just sign up to it and you can easily access the dashboard. Just click on this add new site, then click on this deploy manually. So now you will have this option. Just go to your folder. Okay, so my folder name was chai Dapp, right? In the Visual Studio Code, I will go to this client folder, and inside this I will select this dist, and I will upload. So I will upload. Let's wait for it to get upload. And once this will be done, we will be having a running decentralized application. Wonderful. So this is done. Once the build is complete, means once it is uploaded on Netlify, you will have this particular link. Okay, just click on this link and we will definitely change the link. So you will see that as soon as I have clicked on this particular link, and you can also, access my website using this particular link, you have to simply go to MetaMask, then go to, next, select. Now, whosoever will be going to this particular website will be able to access this website. Okay, so let me refresh, and yes, we have the whole data of our website, right? So the each and everything of this website will be visible to any person who have this MetaMask wallet, and he can access the data available on this website. Now it's time to change the site name, right? Let us go to the setup custom domain, and in this I will have, let's say this time, no, let's say coffee Dapp. Okay, because I have already created a chai Dapp. So coffee buy. Okay, let's say coffee buy, and I will verify. Let me check. Okay, it is an invalid domain name. Okay, I think let's me go back. Okay, I think I was on a wrong option, because it was actually asking for a real domain, but I do not need to go there. I have to simply go to this options field. Okay, edit site name, and in this I will provide coffee buy coffee. Let's say buy coffee, and then just I will save it. Okay, it is already existing, so let's say buy code eater coffee. But it will be a very long name, right? It will be very difficult to remember. So let's have coffee, or let's have chai code eater, something like this. Anything, save it. Okay, so now we have our decentralized application running on chai codeeater.netlify.app, and I will share the link in the description of this video so that you can also access this website. But the only thing that is required to access this website is that you must have actually MetaMask wallet. Otherwise, you will not be able to access this website. Okay, so connect, refresh, and this is done. Oh, it's so great, right? This is great. So I hope you enjoyed this video and you enjoyed the journey of creating our own decentralized application. We have seen how to create our own decentralized application in a step-by-step manner, right? We first uploaded the smart contract, means first we first designed our smart contract, the business logic of our smart contract, then we deploy it on the test network, and now after that we created our React.js code, and then with the help of Ether.js we interacted with our smart contract, and we have seen each and everything in great depth and in a step-by-step manner. So I hope you enjoyed this particular course, and if you have, please do click on that like button. And if you are new to this channel, please subscribe this channel, because I am regularly going to upload new blockchain courses on this channel. So meet you soon in the next video. Till then, take care, bye bye. And if you have any doubts or queries, you can ask me on Instagram or LinkedIn, or also in the comment section of this video. Thank you so much, guys. Meet you soon in the next video.